How many ordered pairs make both of these Boolean algebra expressions true? One way to do this exercise is to list all the possible ordered pairs of A and B, meaning if we put falses and trues in the two variables A and B, there are four possible arrangements: false, 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 true, true, false, and true, true. So let's first consider the left expression here. By plugging in this first test case, false and a false, in other words, two zeros for the A and B, this expression can be rewritten as this. Then simplifying the expression, following the identities of Boolean algebra and following the order of operations. I'm sorry, that was a zero, plugging zero in. So right now we are considering this first test case, 0, 0. Working from inside the parentheses out. 0 or 0. According to a truth table, if you have 0 or 0, that simplifies to 0, also known as false. Just as 0 plus 0 is 0, so is 0 or 0. Rewriting everything else, we're left with this expression. A false ANDed with a false, or 0 times 0 simplifies to 0. I rewrite the not, and the not of a false is overall a true. So this expression does indeed work out to be true with this pair. So I'm just going to number this my expression number 1, make a column here for number 1, and put this 1 in here. And now I redo my steps, but I plug in a 0, 1 ordered pair. So 0, 1 plugged in, where now there's a 1 for B. So let's just consider this to be a 1. A 0 or a 1 is the same as 0 plus 1, that's 1. 0 and 1, well, 0 times anything overall is 0. And the not of 0 is true. So this does indeed work for expression 1, it's true. And I plug in the next pair, 1, 0. In that case, I would have a 1 in here for this A, a 1 for this A, and a 0 here for the B. 1 plus 0 is 1. 1 times 1 is 1. The not of a 1 is false. So it turns out this third ordered pair does not make a true. So this would be false. I forgot to put in the 1 here to show that this was actually an ordered pair that makes expression number 1 true. And my next pair. Let me update my chart here. We've already tested these 3 ordered pairs right here, and now we plug in 1s for both operands. So if this is a 1, and this is a 1, and this is a 1, 1 plus 1 is 1, 1 times 1 is 1. The not of 1 is false. That is not what we want, so this would be a false there. Okay, so we've fully tested out expression number 1 with all 4 ordered pairs, and now we're ready to move on. Put my notes in here again, they got erased. These were both false. Now expression number 2, over here on the right hand side. We're finished with that expression from the left. Now we're considering this expression, and let's plug a false and a false in. Okay, I'm going to show you a trick. Because of this AND that executes after the parentheses, the only one way that all of this would be false is if A is true. Because if A is true, the not of a true is a false, and false times anything is false, which actually eliminates that as a possible ordered pair. So in other words, if A is a 1, it is not possible to have a true. So that rules out, for expression number 2 over here, this and this, where A is 1, cannot be possible solutions or answers to this exercise. So we actually only have to consider the ordered pair 0, 0 and the ordered pair 0, 1 right now in this expression. So cleaning up my sort of mess here. We're erased a little too much. So let's be careful here, and let's evaluate those other 2 ordered pairs. Here it goes. Let's plug in a 0 and a 0. So if you plug in 0 for this A, the not of 0 is 1, and we have that ANDed with a 0 or a 0, which is 0, and a 1 ANDed with 0 is overall 0, and that is not the true that we want, so that rules out that case. So I have one more possibility. Plugging in this last ordered pair, 0, 1, and here goes. Plugging in a 0 and a 1. Okay, so this is a 0. The not of 0 is 1. We have an AND to rewrite. This A would, we're plugging in that 0 there for that A. We have the OR to rewrite. And this B, we're plugging in a 1 now for that B. So what does this simplify to? Well, the order of operations, parentheses, a 0 ordered with a 1 is overall 1, a true, and a 1 ANDed with a 1, overall is 1. So we do get a 1. So what does this mean now that we've plugged in all the 4 ordered pairs to both expressions? How many ordered pairs make both of these expressions true? Well, of these 4, the only ordered pair that makes both expressions true is this ordered pair right here, because this is a true, and this is a true, and all these other ones have at least one false. All these other ordered pairs. Now, it would be tempting to write as the answer on an ACSL exam that 0, 1 is an ordered pair that sort of works and makes this true. But you would not get points, you would not get credit for that answer, even though that is sort of like the work that went along with this exercise. No, you're supposed to tell the exam grader how many ordered pairs. Well, how many? 1. So your answer to this exercise is just 1 ordered pair, which happens to be this ordered pair. 1 is the answer. Another way to have done this problem would have been to take each separate expression and simplify it using Boolean identities. So I'm rewriting that first expression with a slicker notation, and that would be that could be rewritten in this way using some identities real quickly. I can factor out that A, preserving my parentheses. 1 plus B would be 1, A times 1 is A, not A. So really, this expression is the same thing as not A. And this expression over here, not A times A or B, simplifies to not AA plus not AB. This cancels out the 0. And a 0 plus anything is the anything. So this expression here is the same as not AB, or you could think of it as not A, ANDed with B. So it might be a little bit easier to plug all 4 ordered pairs into these 2 versions of our expressions rather than the larger expressions. That would be up to you, but you should still get it as an answer, just 1 ordered pair, and the same ordered pair, 0, 1, would be the one that makes both expressions true.